I'm Anil Kumar, and in this video we'll try to find asymptotes and wholes of the rational functions. We are given two rational functions to practice. A is f of x equals to x plus 1 divided by x cubed plus x squared, and B is f of x equals to 2x squared divided by x squared minus 1. To find asymptotes and wholes, first step should be to factor and simplify. F of x equals to x plus 1 could be written as x plus 1. You can factor denominator x squared and you get x plus 1, correct? Now x plus 1 and x plus 1 cancel out. So you could write this as 1 over x squared. However, the restriction should be mentioned here that x is not equal to 0 for this, and the factor which cancelled out minus 1. Now as you know, all these restrictions lead to either whole or vertical asymptote, right? The factor which cancelled out is a whole. So we have a whole at x equals to minus 1, correct? And we have a vertical asymptote at x equals to 0, clear. Now how do you find horizontal asymptote? This you find with the degree. Degree of numerator is 1, right? So here degree is equals to 1. Here degree is 3. Now since denominator degree is higher, horizontal asymptote is at y equals to 0. That is x-axis. Is it okay? X-axis. So if you sketch this function, I'm making a very rough sketch, it will look like this. But it's going to help you to understand the concept. We have vertical asymptote at 0, so this is the vertical asymptote. Horizontal asymptote is y equals to 0. Okay, so this is y equals to 0, horizontal asymptote, x equals to 0, vertical asymptote. This function is always non-negative, right? Non-negative. We have a whole at x equals to 1 minus. So if I write minus 1 here, then I get what? I get 1 positive instead, okay? So basically it's a function kind of like this. This is x squared, I'm drawing it present. This is x squared, 1 over x squared, with a whole at x equals to minus 1. So at minus 1, there's a whole, and the value is 1. Do you see? If I write minus 1 here, that is 1 over minus 1 square will give me 1. So this is that whole. Do you see that? That whole. So the function could be sketched as this. Horizontal asymptote, vertical asymptote, and a whole. So I hope you have understood the restrictions. Restrictions, you can now write domain range. Domain has two restrictions. Range is always greater than y, right? So you write here domain for the function is x belongs to real numbers where x is not equal to 0 and minus 1. Perfect. And range, this is extension to what we had been doing. Y belongs to real numbers where y is greater than 0. Perfect. Now let's look into the next one. First step is to simplify. Let's simplify. We have 2x squared divided by difference of squares, x plus 1 times x minus 1. So we have two restrictions here. X is not equal to, when this is 0, minus 1, this is 0, plus 1. Now since there is no common factor, we do not have whole, right? No wholes, no whole. However, we have vertical asymptotes at x equals to 1 minus and x equals to plus 1. How about horizontal asymptote? You can see that the degree of numerator and denominator is same, perfect, 2 and 2. So we have a horizontal asymptote which is ratio of leading coefficient, y equals to 2 over 1. Perfect. Now if you sketch this graph, it will kind of look like this. We have a horizontal asymptote which is y equals to 2. vertical asymptote at plus minus 1. Perfect. This is at minus 1 plus 1. This is y equals to 2. I could write 2 here. The function, you will find x squared is positive. And this part is positive when the values are greater than minus 1, plus 1. And the values are, because it's x squared, look into this. X squared, if I have something less than 1, then this is negative, right? So the graph will be kind of like this. We'll get into graphing techniques later, but approximately. As far as the numerator, this part is concerned, it is like more like 1 over x shifted, kind of like this. Well, from the graph, you can write domain and range, right? Domain is all real numbers except these 2 points. So in this case, domain is x belongs to real numbers, so that x is not equal to plus minus 1. Range is important. Let's write range here. So what we find range is that's greater than 2, right? Where 2 is not included. So 2 to infinity, union less than equal to 0. It could be 0 at x equals to 0, right? 0 to infinity, minus infinity, 0 to minus infinity. That becomes the range. Anyway, you've learned in this video how to find holes, asymptotes, including both vertical and horizontal, for a given rational functions. I'll take few more examples, right, to give you more practice on this. I'm Anil Kumar, and I hope it is a good learning experience for you. Feel free to post questions and share my videos. Thank you, and all the best.